Hello and welcome to the course Programming Language Concept. In today's lecture, we're going to talk about a whole new topic, and that is array. In the last lecture, we have talked about different types of loops, for example, for loop, while loop, and do while loop. So in today's lecture, we're going to talk about the array. Now, these are the topics that we are going to discuss. First of all, we will talk about that what is array, and then we'll talk about advantages of array, and then why we use array and how to use array, array declaration, array initialization, and how to access values of array. These are the objectives and outcomes of basically today's lecture and also the objectives of this whole array chapter. So the objective of the chapter is to introduce students to another powerful construct in any programming language, and that is array. How can you declare array, how you can use array, and then how can you initialize array in different types of array. Then we will talk about the outcomes of today's session. So today we are going to have outcome analysis of array. We will analyze an array and you will be able to analyze array. You will be able to understand how to use array, and also you will be able to clarify different array related concepts. And then at the end you will be able to apply array in any programming language. So references, remember that object-oriented programming, Robert Lefort, chapter number 7, you can find the topic called array in this chapter number 7 of the book Object-Oriented Programming by Robert Lefort. And there is another reference book, and that is chapter number 4 of the book Detail in Detail, How to Program. So you can also search, there are plenty of online resources to learn array as well. Now, first of all, the most important question in your mind would be that what is array? So let's try to understand that what is array, and then we will move to the subsequent topics. First of all, to the point, this first point is array is a group of consecutive memory locations with same name and same data type. Remember that this is basically a group of consecutive memory locations. Consecutive means successive memory locations in a sequence-based memory locations or in a continuous memory location. So basically, array is what it is, a group of uh, consecutive or a continuous memory locations with same name. Remember that this group of elements or this group of continuous memory location will have the same name and also the same data type. For example, the data type for all the elements available in this group would be integer or it may be float, and also with the same name. So the second point says simple variable is a single memory location with a unique name and data type. Remember, this is what you have learned about the single variable, that single variable, for example, integer a. So this has a unique name. The unique name is a and its data type, and that is integer. So that's why we say that simple variable is a single memory location. Now, for this integer a, memory location will be reserved. So one memory or single memory location will be reserved for this single variable or simple variable. Now, array is a collection of different memory locations. If we have a simple variable, now simple variable is a single memory location, but array is basically a collection or a group of different memory locations. All these memory locations have one collective name and type. Remember that, for example, if there are 10 consecutive memory locations allocated for one array variable, then all these memory locations must have one name and one data type. For example, all these 10 elements or all these 10 memory location should store only integer if the type is integer. Similarly with the name as well. So it has a unique name and a unique and a similar data type. Now the memory location in the array are known as elements of array. Keep this thing in your mind that the elements, the memory locations that we are talking about, these are basically called as elements of the array. The total number of elements in the array is called its length. Now, if there are 10 elements in an array, or if there are 10 memory location, then we can say that the total length of the array is what? That is 10. So basically, length is what? Length is basically the total number of elements in the array. Each element in the array is accessed with reference to its position of location in the array. Now, each element, for example, 2, 3, 4, 5, whatever element you have stored in a particular memory location, that will be basically reference, or it will be accessed to its position of location in the array. Now, this position is called what? That is called index, or we also call it subscript. Each element in the array has a unique index. Keep this thing in your mind, that unique index is basically position. So the position of the location on which a particular element is stored. That's why this element, or each element, should or must have a unique index. Now the index or subscript of first array element is 0. Remember that the indexes of array element always starts from 0, and the index of the last element is length minus 1. If, for example, the total length of the array is 10, so 10 minus 1, ninth would be our last index for the last element. The value of the index is written in brackets along with name of the array. You will see that how can we basically write the value of an index. So brackets are used to specify that there is basically the index. Okay, array is what? This is basically collection of similar data types whose values always stored at a contiguous adjacent memory locations. Contiguous or adjacent memory locations. Now, contiguous is basically consecutive, okay? Consecutive memory location or continuous memory location. Array name is also called subscripted variable. Now, why we call the array name as subscripted variable? Because it is using subscript. Fine. That's why we call this array name as subscripted variable. So obviously, along with loops and decision control structure, array is a powerful feature of any programming language. Now, array are used. Why we are basically using array? Array are used to store a large amount of similar kind of data. So if there is a large amount of data and the data type is similar, we can use array. There is a very good example. The example says that suppose the user wants to store the marks of 100 students and declares 100 variable. So what is if I ask you that you need to store the marks of 100 students, now what you would do for each individual student's marks, you are going to declare individual variables. So if there are 100 students marks you are going to store, it means that you are going to use 100 separate variables. So again, this is very much time consuming process to use these variables individually. So if you are using these 100 variables individually, then obviously it's very much time consuming method. Now this process can be simplified by using array. How can we simplify this process? Is that an array of 100 elements can be declared to store these values instead of 100 individual variables. So only a single variable with 100 elements will be declared instead of 100 individual variables. Advantages or uses of array. Remember that array can store a large number of values with a single name. As we have discussed that we can basically store a very large number of values with a single name. So array are used to process many values easily and quickly. So arrays basically used to process values very fastly, because we will use only single variable name instead of 100 separate variables or 1000 separate variables if we are going to store a record. The value stored in array can be sorted easily. Again, sorting is basically a topic which is related to the organization of different elements according to ascending or descending position. So you can basically organize or you can sort the values easily using array. Also, a search can be applied on array easily. You can also apply different searching techniques, like there is binary searching, there is linear searching. So these searching can be easily applied using array. Now, why we use array, the question might be in your mind. So let's have a look at the importance of using array. Now, to remove the limitation of ordinary variable, we use array. Now, we know that ordinary variable can store only one value at a time. For example, if this is a variable and we have initialized a new value of this x, and that is 10, so the value of x is 10. Now, after this, we have stored a new value. We sort of want to store a new value in the same variable, and that is x. So we try to store 20 in x. Now, um, when we see the output of this statement, cout x, so it means that we are printing something, and that something is basically the value of x. Now, when you see the output after this statement, guess what will be the output? Obviously, the output would be 20, not 10. Why? Because we have discussed that whenever we are using variable basically changes its value. So in this case, if the initial value of x is 10, now after this statement, the value of previous value of x will be removed, and new value, which is 20, that will be stored in x. So the output of the above statement will be 20, as in the variable x. Initially 10 stores there, but after x that's equal to 20, after this statement the compiler overwrites the value of 20 in x. Thus, to store more than value at the same time, we use array, but all the values in array must have the same data type. Now all the values must have the same data type. Keep this thing in your mind. If you have declared a float array, so in that case all the elements or all the values must be float. Or if you have used the integer array, declared an integer array, then all the elements of this integer array must be integer. Now another question might arise in your mind, and that is how to use array. So to use array in C++, we must consider the following important question. Now before discussing these questions, let me print you the output of this program. So we would go to the div C++, and here what we are going to do is that we are going to uh, include the header files and using namespace std, and then we have this main. So first of all, as usual, that you are going to declare the variable, and then we are initializing this variable with a value of 10. So after this, what will happen? What we are going to do is we're going to store 20. Now what we are trying to do here is that we are trying to store a new value here in x. But what will happen if I print here x? Let's try to save this and see the output. Now you can see the output of x is what? That is 20, not 10. That is basically the limitation of the ordinary variable, that we cannot store more than one value in ordinary variable. So for this reason, we are using array. Now array basically stores more than one value at the same time. Fine. So let's try to go back to the slide and discuss this, how to use array. The question is that how to use array. First of all, we will talk about how to declare array, and then how to initialize array, how to supply values at runtime, and then how to access the values of array, how much memory the compiler reserves for different types of array. So the first point here is array declaration. Now array declaration, just like ordinary variable, what you normally do, you specify the data type. Okay, like let's suppose you want to store an integer value, so you specify the data type and then you specify the name of the variable. In the same way, we can declare array as well. So first write the type of array. What values you are going to store in array. You need to specify the type first. The second thing is write the name of the array. The second thing that we have to do after specifying the type, just like we were specifying the name of the variable, so the same way we are going to write the name of the array. Now name of the array may be any name, but it must follow the rules of an identifier. Keep this thing in your mind. The rules of identifier are also applied to the array, because array is also one of the identifiers. Third, write the opening and closing bracket. Now let's try to assume that we are going to store integer value. So integer values in the array. So what we did here is that we have specified the data type. So the values will be integer. What next we are going to do? We're going to write the name of the array. Assume that A is the name of the array. And third basically write the opening and closing square brackets. This is basically the third point. Inside the square bracket, you must mention the size of the array. For example, you want to store 5 elements, 10 elements, 6 elements, whatever. You need to specify the size of the array. So what you can do, assume that I want to store 10 elements in this array. So that's why I have to write this inside this bracket. And then obviously the most important thing, do not forget, and that is to write the semicolon at the end of the array declaration. So this is a simple example of the array declaration. Now moving forward, this is called the array declaration. The first point here is the data type. The second point here is the name of the array, and 6 is the size of the array. Here we have put the size of the array inside the square brackets, and then we have used the semicolon. So this statement is what? This is called as the array declaration. The above array will reserve 6 spaces. Spaces in memory will reserve spaces in memory for 6 integer values. Now for 6 elements or for 6 integer values, okay, this statement is going to reserve some space. For each integer value, the compiler reserve 2 bytes space, so a total of 12 byte space will be reserved for the above array. Now if you are using Turbo C or Turbo C++, obviously in that case for each integer element the compiler is going to reserve 2 bytes. But if you are using modern day compilers, for each integer value 4 bytes of space will be reserved. So a total of how much then? A total of 24 bytes space would be reserved for the above array. If let's assume that there are 10 elements. Now in that 10 elements, then there should be 40 bytes, because for each byte we have what? We have 4 bytes to be reserved for the each byte. Okay, so this is basically the array declaration. Moving forward, this is basically the memory mapping of the array. Like if you declare an array in the previous example, here we have declared an array of 6 integer elements. Okay, that's why it's going to take 24 bytes. So how this will be mapped in the memory? This is how it will look like, and this is basically we call this as the consecutive memory location, or adjacent memory location, because each memory location is adjacent to the other. So this memory location, which is basically A0, uh, it will be reserved for the first element. Remember that array indexes starts from 0. So the last element would be length minus 1. The total length of the array was how much? It was 6. Okay, it was 6. Now we discussed that length minus 1. So length is 6. 6 minus 1, that becomes 5. So the last element of the array is going to be stored at this index, a 5 index. Okay, so these are the memory mapping of the array. 1, 2, 3, 4, 5, and 6. Total 6 elements are there. So far we have not stored any value. That's why these are basically empty. All the memory locations are empty. These are basically the indexes or the position on which a particular element of the array is going to be stored. So this is array initialization. The next thing that comes into your mind, that is what that might be, that how can we initialize an array. uh, like if we go back to this dev C++, I told you that we can initialize a simple, we can declare a variable, okay, like this, a simple variable, but we can declare an array, okay, an array like this. Here we need to specify the size, okay. So this is the declaration of the array, and this is the declaration of the simple variable. It means that here only one value will be stored in X, but here 6 different values will be stored in one variable, and that is the array variable. Fine. So the same way, if I ask you to initialize a variable, a simple variable, this is how we basically initialize a simple variable. But there is again the initialization of the array. So this statement is actually used to initialize array. The values would be stored at different location. For example, integer a is the name of the array. The total elements are 6, and then you need to use the curly brackets. At 0 index we are going to store 10. At 1 index we are going to store 20. At 2 index we are going to store 30, and third index we are going to store 40. Fourth index we are going to store 50, and at the last index or last position we are going to store 60. So this is what this is actually called as the array initialization. Now here this is that 0th index, okay, this is the first index, and this is the second index, this is the third index, this is the fourth index, and this is the fifth index, okay. So we have discussed that the last element would be stored at length minus 1 position, and this is basically, these are the different 6 integer values that we have stored. Remember that you do not store any other value like 10.5, which is real value or which is a floating point value, because here you have declared the value, the array, and that is integer. So the values or all the values must be integer type. These are the 6 values, and the 6 values are stored at different indexes. Moving forward, now here you can see, suppose this is the A. A is the name of the array, and then here we have stored different values: 10, 20, 30, 40, 50, and 60. This is the memory mapping of array initialization. When you initialize array, this is what going to happen in the memory behind the scene. So on 0th index we have 10, on 1 index we have this, second index we have this value stored, and third index we have stored this, fourth index we have stored this, and fifth index we have stored this. So basically index represent the position on which we have stored a particular value. Now the next very important question is, how can we access values of the array? How to access values in array? Each individual element of an array is accessed by specifying the following. First of all, we need to specify the name of the array and then the index of the array. We will see through example, and then you would understand this point, that how to access the element of the array. Syntax: the syntax of accessing individual element of an array is as follow. First of all, you need to write the array name, and then index of element, and then semicolon. Array name, it indicates the name of the array, and it indicates the index of the element to be accessed. Okay, index, basically it represents the index of the element to be accessed. Now to access the value of an array, we must use its subscript as under. For example, we want to access a particular element. and that particular element resides or it is stored at third index. We are going to print this thing that is 40 on the 40 will be printed on the screen because we have used the index and that was third and also the name of the array. Now if we go back to the div C++, okay, this is how we are going to access the element of the for example I want to access the I want to access the element located at fourth index. Fine. So fourth index, this is 0, 1, 2, 3, and 4. So 50 will be printed on the screen. Let's try to, uh, you can see 50 is printed on the screen. Fine. Now let's assume you want to change this index number and you want to access the value which is located at the second index. So we are going to run this program and you see that we have the output that is 30 because array indexes starts from 0. That's why this is the 0th index, this is the first index, and this is the second index. So third element is basically stored at the second index and that is 30. Now if let's assume that we are going to change this index value, okay, to third. Now you can look at the result here. The result is now 40 because the index is changed. Okay, so this way you can access individual element. The above statement will get printed the value lying at the location 3. Okay, and thus 40 will get printed on the screen. So you have seen it through your on your own eyes. Um, Fine. So now this is how we are basically accessing different elements again using using the different index values. So for example, there are 6 elements. Okay, now we want to individually store different values at individual position. So how can we do this? Let's try to go back to this IDE. Okay, assume that for example the array name is what, that is marks, and we're going to store um, six values. So how can we access individual elements? By specifying the name of the array and then the index. So on 0th location I'm going to store 10. Fine. Similarly on this location I'm going to store 20, and then I'm going to store 30 on this location, and then marks 3, that is 40. Okay, and I'm going to copy this thing 40, so next will be 50, and now 50. Yeah, this will be enough. So 1 2 3 4 5, and this is that 60. So we also need to change the index or the location or the position. Fine, this should be the last uh, index. So the last element is stored at this index, at the 5th index. So this is how we basically access different individual elements. Now let's assume that we are going to print value at 0th index. So what we normally do, we are going to write the position or the index along with the array name. Fine. And similarly, array name is marks, and then what value is going to be stored at this first index. So let's try to copy this and let's try to paste this like, okay, so this is the first, this should be second, third, fourth, and this is the fifth. Now we have accessed the individual elements. So first of all, whatever value that is stored at this location, okay, marks 0, that will be printed 10, and then we will see what value is stored at this position, marks 1, that will be printed, and then marks 2, then marks 3. then marks 4, and then marks 5. So let's try to run this program and see the output. You can see this is the output of a simple program which we have used for accessing individual elements. Okay, you can also take input from the user. Now, how can you take input from the user? In that case, you need to remove this thing. Instead of this process assigning value to individual element, you can use cn object. For example, marks 0. It is going to we are going to input value and then cn marks, that is 1. Okay, let's try to copy this code, these two, and then paste it here, paste it here. Okay, so this will be the second, this will be the third, and this fourth, and this fifth. Now when we run this program, what will happen? The program, okay, we need to input a message for we need to print a message for the user as well. Please enter values at different array locations. Fine, so this is what this is, a simple message, and then /n. Now let's try to run this program and check the result. Here a message is printed. So what we are going to do, we need to store values. This will be stored at 0 index. You will see in the output. Okay, this will be stored at the 1 at the first index, and then this will be stored at the second, then this will be stored at the fourth index, this will be stored at the fifth index, and this will be stored at the sixth location. So this is how the values are basically printed. You can see 10, 20, 30, 40, 50, and 60. So try to practice on these things, okay, in order to access individual elements by different meaning. Now this whole process can be very much easy, okay, if you initialize an array. In that case, initialization would definitely help us in reducing the code. Okay, for example, 10, 20, 30, 40, 50, and 60. Fine. So this is basically, let's suppose we need to output of output of array. Okay, so this will be the output. Fine. Now when we run this program, you can see output of array 10, 20, 30. Now the whole bunch of those code is that code basically it is reduced just because of this initialization process. Okay, we can also reduce this, but for that we have to wait a little more. So the above example declares an array marks of type int with 6 elements, not 5 elements. So we are going to change this to 6 elements. It accesses all the elements of the array individually to store different values. It accesses all the elements of the array individually to store of the array to individually to store different elements. You have seen this, okay? Marks 0 indicated the first element, and marks 5 indicates the last element of the array. This is the basically last element, and this is the first element. Now here, this is how the memory mapping is shown here. So we need to input values as well. 30, 40, this will be 50, and this will be 60. Fine. So this is how basically you can see marks on mark 0 we have stored 10, on marks 1 we have stored 20, marks 2 30, marks 3 40, marks 4 50, and marks 5, that is what, that is 60. So this is how things are working in the array. Moving forward, input and output values of an array. Input and output values of an array. The process of input and output is what that is basically with arrays is similar to the input and output with simple variables. Like simple variables, you can also use the input and output for the different arrays. The cn object is used to input values in the array. The cout object is used to display the values of array. Obviously, cout is used for output, cn for input. However, the use of these objects with individual elements become very time consuming. This becomes very time consuming because each element is treated as a simple variable. Now, the solution is loops are frequently used to input and output data in the array. The use of loops with array makes the process of input and output faster and easier. Now, it also reduces the code written for this purpose. Uh, so, uh, just like ordinary variable, for this I would go back to this div C++. Here again, what I can do is, if let's suppose I want to use a simple variable, okay, then what I can do, let's assume that I want to take input for the simple variable cout, please input value, okay, please input value in A. So this is the process for the simple or ordinary variable. Now A, and after this we can print the output. Output of A is equal to, here we use cout again. So this way you can also use the cn object as well as the cout object for the array. Now how can we do this? Let's try to run this program and see the result. So first of all, we want to input value, and that value is stored in A. Now here it is printed on the screen. You can also use the same way for the array elements. For example, you are going to we will make it short. Suppose that we want to store 3 elements in this array variable, okay, so for this we have to declare array first. This is the declaration, and then we need to input, then we need to print a message, please enter values in array. Fine. Now after this we are going to access individual element like this, marks that's equal to 0, and then marks total number, or how many there are basic total elements, or 3. So the last element would be 2, index 2, marks that is 2. Okay, this is the last element. So that's why we have discussed length minus 1. Length is 3 minus 1. So 3 minus 1, that becomes 2. Okay, so this will be the uh, element, the position of the element or the index of the last element. Now, how can we access cout output of array elements? Fine. So output, again we have to use cout marks, or we need to directly print the values stored at different locations, and line, and then cout another statement, another cout statement, marks 1, end line, and then marks 2, which is the last index for the last element to be stored in array. So this is done. Let's try to run this program and see the output. Now here the program is asking me, where is our control? Our control is here at the 0th index. So assume that we are going to input 90, and that will be stored at this particular location, 0th location. Again, it is asking me, now the control is here. Okay, so we need to input a new value that will be stored at this location. After this, it is again asking me, see the cursor is blinking, so it means it is waiting for me. So I'm going to input 60. By the time I input 60 and I press enter, this statement will be printed along with the values that are stored at different indexes. So you can see output of the array elements is 90, 80, and 60. This 90, 80, and 60 is because of these different statements that I have written here. So this is how input and output basically works, but it works without array, without use of loop. Now we can use loops as well in array, and this then it becomes very much powerful. So how to access elements using loops? It is basically an easier and faster way of accessing array element, that is using loop. The following example, this is the example array declaration, and this is how we basically use loop, and this is marks. The above example uses for loop to store different values in the array. It uses the counter variable I as an index. In each iteration, the value of I is changed. So let's try to write a simple program, okay, using array in both loops, and then we're going to move forward. So for example, the first thing is that you need to do is that you need to declare variable. So I'm going to assume I'm going to store 5 elements. That's why I have to use please enter values in array, a simple message for the user. Okay, and then now what I'm going to do, uh, I'm going to use loop here. That's why I have declared a counter variable. So for because array index starts from 0, that's why the value of I should be 0. I less than what? I less than 5. So I must be less than 5 because the value of I is started from 0. That's why I is less than 5. I plus plus, and after this we are going to use the cn object. Okay, the cn object along with this I represent the index. Okay, so after this we can print a simple another message. The output of the array elements are, this is end line, and we need to use another loop here for the output. Remember, this loop is used for taking input from the user. Okay, while this loop is going to display the elements that is stored at different locations. So I less than 5, again true, and I plus plus. So after this what will happen, we are going to use the cout, and we are going to use marks, again I, the index I here represent the index. So how this program works, let's try to understand. First of all, I have declared an array of size 5. It means 5 elements will be stored in this array. Then I have declared a counter variable. This counter variable will be used inside the loop. A message will be printed for the user. Now the user is going to supply value, and those values will be stored at different indexes. For example, the initial value of I is 0. So here condition will be checked. 0 less than 5, condition is true. When the condition is true, the program is going to ask the user to input value. It marks 0 because the value of I is what? That is 0. That's why user is going to input a value, okay, and that will be stored at marks 0. After this, the loop would have or might have completed first iteration. Then the control will transfer to the increment part. The value will be incremented from 0 to 1. So here again condition is checked. 1 less than 5, condition is true. That's why the program is going to take input for one more time, and that will be for marks because the value of I is now 1. That's why marks 1, the value is going to be stored at marks 1. After this, control transfer to I plus plus, the value will be incremented to 2. 2 less than 5, condition is true. So this time I will be replaced with 2 marks 2. The value, the user will provide value, and that will be stored at marks 2. After this, control will transfer to I plus plus. The value of I will be 3. 3 less than 5, condition is true. That's why marks 3, the user will provide value at marks 3, and that will be stored at marks 3. After this, again the control will transfer here. The value will be incremented to 4. 4 is still less than 5, condition is true. Marks 4, the user is going to provide value at marks 4. After this, control will transfer to this part. Okay, the value of I becomes 5. So 5 is not less than 5. That's why the condition would be false, and the control will transfer to this statement. This statement will be printed on the screen. Again, the loop starts from the beginning. Okay, this loop is used for displaying the array elements stored at different indexes. So array is in I is initialized from 0, 0 less than 5, and after this the condition is true. This statement will be printed whatever value that is stored at marks 0 location, that will be printed, and then control will transfer here I plus plus, the value of I becomes 1, 1 less than 5, condition is true. So marks 1, the value of marks 1 will be printed. Again, the control will transfer here. It will become 2, the value of I become 2, 2 less than 5, condition is true. Marks 2, the value of marks 2 will be printed. So this process is continued until the value of I becomes 5. When the value of I becomes 5, again the condition would be false and the loop will stop. So let's try to run this program and see the result. So first of all, we have to input values. Now, where is the condition? Where is the control? Control is it marks 0. So we have to supply a value. A value would be 50. Let's assume after this, the control is it marks I and marks 1. Okay, so we are going to supply value and that will be stored at marks 1. After this, marks 2, the control is now at marks 2, so at marks 2 I'm going to store 90, and then marks 3, this is the marks 3 location, and this is the marks 4, which is basically the last index. After this, the loop will be stopped because the condition will be false. This statement will be printed, and after this the loop will again start from the beginning. So all the values that is basically stored at different indexes, the loop will go through all those values and all those values will be printed on the screen. You can see 50 was stored at 0, 4 was stored at 1 location, marks 1 location, 90 was stored at marks 2, 86 was stored at marks 3, and 60 stored at this location. So this is how you can use loops frequently and an array. So let's try to go back, and here types of array. Now there are different types of array. For example, if you have, like we have integer array, char array, and float array. If we have 6 elements, okay, so modern day compiler is going to have 24 bytes, or it's going to reserve 24 bytes memory. But if you are using Turbo C and Turbo C++, in that case, it's going to take 12 bytes. Similarly, A6, if there are 6 characters, an array of 6 characters, then obviously one character is going to take 1 byte. So 6 into 1, that becomes 6 bytes. Obviously, if you're using float, then 6 float element is going to have 24 bytes of space in memory. So the summary, an array is a collection of similar data type values. You have seen similar data type values. For example, if you have declared float array, then all the values must be float. Or if you have declared character array, then all the values will be character. Or if you have declared integer array, all the values will be integer. Now all the values of array will be stored at contiguous memory location, adjacent memory location. You have seen the memory mapping. The first value of array will store at location number 0. Okay, so the last value will store at location number 1 less than the size of the array. Length minus 1, keep this thing in your mind. Array name is also called subscripted variable. Why? Because it is using subscript. To access particular item of an array, we use its subscripts, and also loops are frequently used in array. So thank you very much for watching this video. I hope that you have learned the concept of array, that what is array. I hope you have learned the concept of how can you use array. I hope you have learned how to declare an array, and then I hope that you would now know how you can initialize array, how to access different different indexes of an array or different elements of an array. So I hope that now you might have learned how you can access individual elements without loops, and how you can access individual element with loops. So thank you very much for being attentive.